All right, today we're going to talk about the single biggest reason most AI projects fail. And it's funny, we get so caught up in these super complex algorithms and massive computers, but the real culprit? It's usually hiding in plain sight. And it's not nearly as glamorous. Let's get into it. So, what is this hidden killer? The thing that just completely derails so many amazing projects that are trying to teach computers how to see? I mean, is it the model itself? The crazy long training times? The super expensive hardware? Well, the answer might surprise you. And there it is. It's the data. It's not about having the smartest algorithm in the room. It's about having the best, cleanest evidence to work with. Think about it. If you feed an AI messy, incomplete, or biased data, you're going to get messy, unreliable results. It's that old saying, right? Garbage in, garbage out. So the most critical work in AI isn't always what you'd think. That's right. The most important job in computer vision isn't just being a programmer, it's being a data detective. You've got to be the one to meticulously investigate your dataset, searching for clues, for weird inconsistencies, for hidden biases, all before your model ever sees a single piece of it. Okay, so before any good detective can start analyzing the evidence, they have to understand what they're even looking at. So our first step is to figure out how a computer sees an image. And spoiler alert, it is not at all like how you and I see things. For a computer, our entire visual world, everything we see, boils down to one single thing, the pixel. It's the smallest possible dot of color on a screen. So an image isn't a beautiful, cohesive picture to a machine. Nope. It's just a giant grid, a massive matrix of numbers where every single number represents one of those tiny pixels. Let's make this real. Take a simple everyday object like a stop sign. To us, it's a red octagon. It means stop. It has context. But what does a computer actually see when it looks at this? As we zoom way in, those nice smooth lines just dissolve. The image totally breaks down into a mosaic of little colored squares. And these are the pixels we were just talking about, each one just a single solid block of color. And here it is, the final reveal. Inside the computer's mind, this grid of numbers is all it sees. Each pixel is just a set of 3 numbers representing its red, green, and blue values. That bright red pixel, that's just 255,00. White, that's 255, 255, 255. That's it. This is the digital evidence our detective has to work with. Now, just a quick but really important distinction here. You might have heard of vector images. They use math to draw lines and shapes, and they're awesome for things like logos because you can scale them forever. But in the world of computer vision, we almost exclusively deal with raster images, the kind that are made up of that grid of pixels we just decoded. Okay, so now that we understand the evidence, it is time to open up our Data Detectives Toolkit. Let's take a look at how we can investigate these millions and millions of pixels to find hidden problems before we even think about training our AI. A good detective has a bunch of techniques. We can count the unique labels to see how diverse our data is. We use frequency counts to spot imbalances. For example, what if we have 1,000 pictures of stop signs but only like 10 of yield signs? Well, our AI is going to become a stop sign expert, but it'll be terrible at identifying yield signs. We also use tools like histograms to find outliers. Maybe an image that's way too dark or super blurry. Now, one of the most powerful tools in our kit is something called the kernel. The best way to think about it is like an automated magnifying glass for the AI. It's a small grid that slides across the entire image, specifically searching for patterns like edges or corners or different textures. This is how modern AI really starts to make sense of all those numbers on its own. So, our investigation is done. We've found the flaws in our evidence. Now comes the crucial part. We have to clean it all up and prepare it for trial. This is how we make sure our AI model, which is basically the jury, can reach the right verdict. And this whole preparation phase really boils down to 2 main stages. First, there's image pre-processing, which is all about cleaning and standardizing the images. And second, there's data augmentation, which is this really clever trick for making our dataset even more powerful. Okay, data augmentation is such a cool technique. We're not actually adding brand new images. Instead, we're creating slightly modified copies of the ones we already have. What this does is it creates new perspectives. It teaches the AI to recognize an object even if it's tilted or partly cropped, or maybe the colors are a little off, just like it would be in the real world. And here are some of the most common ways we do this. We can crop an image to focus on what matters. We can rotate it just a little bit, flip it horizontally, or even shear it to simulate looking at it from a different angle. All of a sudden, one good image can become 5, 10, maybe even 20 different training examples. It makes our AI so much more robust.
Then you've got even more advanced techniques, like something called opening. It's a really neat two-step process. First, an operation called erosion basically shrinks the object in the image. So imagine a satellite photo with a single stray bright pixel, like a sensor error, in the middle of a dark forest. Erosion can make that tiny speck of noise just disappear. Then dilation expands the main object back to its original size, but now it's much cleaner. It's like we're digitally polishing the evidence.
So, we've investigated the evidence, we've cleaned it up, we've prepared it for trial. Now it's time for the final verdict. Why does all this detective work actually matter so much? Well, the results are pretty undeniable. Good data preparation leads to way higher model accuracy. It significantly reduces bias and those skewed, unreliable outcomes. And get this, it can even reduce the time and money it costs to train the model in the first place. It's a total win-win-win. So let's sum it all up. The biggest killer of AI projects isn't the model, it's the data. Remember, a computer just sees a grid of numbers, and your job as the data detective is to investigate those numbers. By cleaning, preparing, and augmenting your data, you don't just build an AI that performs better, you build one that's far more reliable and robust out there in the real world. But this leaves us with one final and really crucial question to think about. Through all this cleaning and cropping and augmenting, we are making choices. So, are we teaching an AI to see the world as it truly is? Or are we just teaching it to see our own curated, edited version of it? That's definitely something to chew on. Thanks for tuning in.